Corporate finance practice problem using Excel. Future value of an annuity where we have an interest rate change. In other words, we do the calculation for the future value, taking some assumptions into consideration. There's a change and we're going to have to make an adjustment to our projections based on that. Get ready. It's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you'd like to follow along and have access to the Excel worksheet, note that we are in the Practice tab as opposed to the Example tab. The Example tab, in essence, being an answer key. We're going to have the information on the left-hand side. We will populate that into the blue area on the right-hand side. It will be a fairly long problem because there are multiple components to it, and we will recalculate the same component multiple different times in multiple different ways. If you just like to go through the problem as quick as possible, you can look at how it will be calculated one way and then jump to a further part in the problem. We'll try to mention when that will be taking place as we go. So our scenario is going to be that we have a scenario that we want to be saving up $400,000. We want to get to that point in 15 years, and we're going to do so by making semi-annual payments with assumed rate at 10%. So we're going to assume 10%. We're going to be putting payments in semi-annually every 6 months. And we want to get to $400,000 after 15 years. Therefore, how much do those payments need to be? That's going to be our first calculation. Then we're going to assume that there was an issue in that we now think that the rate increased to 12%, like in the middle of our problem. So we're going to say 6 payments in, we now have decided that the rate should now be 12% as opposed to 10%. And we have already calculated the annuity at the 10%. So what type of adjustments would we need to be making at that point in time? Because and that would mean that we would have to figure out how much we had accumulated up to that point for the 6 payments at the 10%. We'll have to take that and assume that we're going to get a return on that at the new 12%. And we're now going to have to make another basically annuity, assuming now the new rate from that point in time forward using the 12%. That's going to be the new component. So let's do the old component first. We've seen this type of problem before. I'll do this a bit more quickly because of that, and then we'll make the adjustment, which is kind of the new thing to it. So we're going to start up top. I'll make this area green. That's where our focus will be first. So we're going to try to find the payment. You could do that with the calculation down here with a formula, use it formulaically. The payment is something we're going to kind of back into. We know it's a future value of an annuity. We know what the future value needs to be. That's our goal. 400,000 equals. P would then be the unknown. 1 plus R. R, a little bit tricky because it's 10% per year, but the payments are made semi-annually. Therefore, it would be 10 divided by 2 or 5%. To the N, number of periods, also a little bit tricky because years 15, but periods because semi-annually, 15 times 2 or 30 periods, minus 1 divided by R. Once again, same R here in that we would have 10% divided by 2 or 5%. Then we can solve for P algebraically. That's one method that you can use. We're also going to use the method that we're going to put this into our table format, not reworking it algebraically, but using goal-seek to then find this amount. We will then also use that same concept to do the same thing with a function, which is more likely to be done in Excel. We'll also use the payment function, which isn't really what we're concentrating on here, but that's another function that you can use that would be quite easy to find the payment as well. So I'm going to go back on over. Let's do our calculation. So 1, you do it algebraically. 2, you do it with our trial and error or goal-seek method. And then 3, functions, either the future value function or we can use the payment function, which would be the fastest way to get there. So I'm going to assume that I'm just going to make an assumption of 1,000 to start off with. And that's going to be our unknown that we'll be adjusting to get to the proper number. And then we're going to go down here and say we have this item down here, which is going to be P times 1 plus R to the N. We want to get into the numerator because it has more going on. I'm going to bring this into the inner column. I'm going to say 1, and then R is going to be equal to that 10%, but that's for the year. I'm going to divide it by 2. That's where you got to be careful when it's not yearly. Home tab, numbers, let's percentify that. Percentify, underline, home tab, font, underline. We're then going to sum this up, equals the SUM of these 2 items. Percentify that cell, home tab, numbers, percentify. Then we're going to take that to the number of periods, once again needing to be tricky or be careful here because this is going to be 15 years, but semi-annually, therefore 2 times a year, so times 2. Then we'll underline here. I'm going to say home tab font, and underline. And then we'll go ahead and do the calculation for the 105 to the power of 30 periods. So this is going to be equal to the 105% shift 6 to the power of 30, to the power of 30. Adding some decimals to get this a bit more accurate. Home tab numbers, decimalizing it. And then we're going to subtract out the 1, finally getting to the end of the numerator. So minus 1, underline, home tab, font group, underline, bringing this into the outer column. This equals the 4.32 and so on, minus 1. Adding decimals here, home tab, font group, decimalizing it. That's the numerator. Denominator is just simply R. So this is going to be then the 10% divided by 2 because it's per 6 months. Home tab, numbers, percentify, home tab, font, underline. And then we'll go ahead and divide these out because we got the numerator and the denominator. And that's what we do when we have those. So numerator divided by the denominator, decimalizing it, home tab, numbers, decimalize, underlining it, home tab, font, underline, and there we have it. So now we're going to multiply out the outer columns. This is going to be then equal to the 1,000 times the 66 point so on. Couple decimals here. Home tab, number, a couple decimals. Okay, that's going to be the end result, which will be the future value. Let's type it in, future value. And we know the end result needs to be the 400,000. So now I can change this since they're all linked. I can then change this to like 2,000 and so on and so forth and see the end result, changing it until it gets to where we need to be, or we can use Excel to do that using goal seek. So I'm going to do that by going to the data tab. Going to go to what if analysis and forecast, goal seek. We're going to seek the noble goal of changing this cell to 400,000. Is that 400,000? I got long. Well, 400,000 by changing that cell. That's the goal we seek. And then we're going to say, okay. And then the goal has been realized, making us extremely happy. So then down here, the 400,000, and we kind of backed into the payment. You can use that same kind of concept over here. So 1, algebra. 2, kind of a goal seek type of method. 3, you could then use the payments in Excel, which would be the most common method to use. You could use the future value, which is probably the most common formula. But if you work with these payments a lot, then you would know the payment formula. So let's do the future value formula first with the same kind of concept as goal seek. And I think this is really useful because any kind of function where you don't have an unknown, you can use kind of this goal seek to figure it out in a similar way as algebra. So we're going to put this 1,000 down here as the payment again, guessing that to be the payment. I'm going to then say that this is going to be negative future value, shift 9. The rate is going to be this 10% divided by 2 because that's the yearly percent, and we need to make it a percent per half year or 6 months, semi-annual, comma. Number of periods is going to be then 15 times 2, because once again, 15's yearly. We have semi-annual, therefore 30 payments, 15 times 2, comma, and then we got the payment, which we don't know. We're going to pick this item here. The end result is what we do know, but we're going to kind of back into it or use the goal seek feature to get there. So, okay. So there's the 66. Once again, we know it needs to be the 400,000. So what I'm going to use is the trusty goal seek. So we're going to go then data up top, forecast, seeking another goal. Another goal is being sought. Once we find one goal, we're always after the next one. We want to set this one to be the value of 400,000 by changing this cell. So change that cell to what it needs to be, Excel. And Excel's like, yes, we can seek that goal. And there it is. So there we have that. Now, if you know the payment, obviously if I go in there, that payment, if I have a formula that basically reworks this algebraically for the payment, meaning a function for payment, then I could use that as well. And so that's not really where our major practice is here, but obviously you could do that too. So we could say this will be negative PMT. That's our payment formula, which could be quite useful depending on, what you're doing in finance and whatnot. So this is going to be then the rate divided by 2 again. So the rate divided by 2. And we're going to take that and then comma. And then the number of periods, which is going to be the 15 times 2, comma. And then I'm looking at this item down here. We have the present value we're not working with the present value. What I know is the future value, what I want to get to. So because I can use the same payment for the present and future, so I'm going to put 2 commas there. I'm not using that one. And instead, I'm going to use the future value, which is that 100,000 now, and enter. And there we get it once again, the 602, or which would be the most direct way to kind of find that, of course. Then we could do it with a running balance calculation. Also note this, if you want to jump to the second half of the problem, you could at this point, but we're just going to calculate this a couple different ways here. Running balance calculation. So I'm going to say 1, 2, and then copy this down. Selecting these 2 cells, I'm going to select those 2. We could copy this down all the way down, and that'll give us 30. Home tab, alignment, centering it, and then I could pick up the payment. Now I could use the same goal seek to figure out the payment, but let's just add the payment this time and just see how this kind of running balance will work, just in terms of a running balance type of calculation, which is quite useful in Excel. So I'm just going to pick up the payment here. I'm going to say the value is going to be this, and then when you do your running balance for the interest calculation, we would have to say this is going to be the value before times the interest rate, which would be the 10% divided by 2. So you got to make sure to divide it by 2. And then the payment will always be the same. And then we can add up the prior payment plus the interest and the current payment. And then we would continue that on down. So the interest would be the prior value. Now the value times the rate, which is going to be the 10% divided by 2. Once again, and then the payment is going to be that 6021, and then the value is going to be the prior value plus the interest plus the payment. So then I'm going to copy this down. If I double click on the interest here, I'm going to absolutize this cell, which is the interest cell, and B7. I don't need to do anything to the 2 because it's a hard-coded number. I'm going to select F4 $ before the B and 7 to do so, enter. Selecting then these cells, and I'm going to autofill, putting my cursor on the fill handle, taking it all the way down to the 30 payments, and that once again should get us to that 400,000. So you can kind of see how that works, and you can see what the interest is doing versus the payments that are taking place for it. So then let's do it one more time with the tables. Tables, we can pick up, then the amount is what we do not know. I'll make that yellow. That's what we don't know this time. The table, we can pick up the amount from the table, and we do know the future value, which is the 400,000. So then on the table, we could say this is going to be not 10%, but 5%, not 15 periods, but 30 periods. So 5 and 30. So we're looking 5 and 30. So 5 and 30, 66.439. 66.439, that's what we're talking about. So 66.439. And then I can back into this number by dividing this out. This is going to be the 400 divided by that 66.439. There we have that. Not exactly the same as this because of rounding, tables being rounded to 4 digits. Okay, finally, second part of the problem. We're going to say, okay, now they made this change. And they said, okay, after 6 payments, we now think it's going to be 12% instead of 10%. We're like, but we've done this whole thing. Well, so then we have to say, well, okay, let's do this first annuity for the 6 payments, which were at 12%, which were at 10%, because that's going to give us the balance that we're at this point in time. And then we'll have to figure out the annuity now for the 30 payments minus the 6 payments that we already had, right? So we have to figure out the annuity to figure out, the 6 payments that we've received, doing a future value calculation. Then we have to think about, well, how much can we generate on that lump sum money at the new rate of 12%? And then for the remaining payments, which is 30 minus 6, the 24 payments, then how much are we going to generate on the 24 payments that are now at the 12%? Okay, so first we're going to start off by saying, okay, let's do the annuity for the 6 payments to see where we're at. Those 6 payments, we're at the 10%. To see what lump sum we have that we can then use to invest, hopefully receiving a 12% return on the rest of it. So same annuity calculation, straightforward annuity calculation. So we're going to say, all right, so the payment, we know what the payment was because we got that last time. It's right here. I'm going to pick it up over here so it's more accurate than the one from the table. So there's the payment. Add a couple decimals to that. Home tab, numbers, decimals, and then we're going to say that we have then the 1 plus r to the n minus 1. So I'm going to say 1 And then the rate is going to be, now this is still at the 10%, but then we have to divide it by 2. So it's the 10% divided by 2 because of the semi-annual thing. Percentify, home tab numbers, percentify, underline, home tab font, underline, summing up equals the SUM, those two numbers. Percentify, home tab number, percentify to the number of periods, which is now going to be just the 6 periods, which is the 6 periods down here. Those are the semi-annual periods because that's where we stopped last time. So we're going to say 6 periods and then underline, and then we'll do our calculation. This equals the 105 to the power of shift 6 or caret 6 here, adding decimals, home tab number, decimalize. Then we're going to subtract the 1 to get the entire numerator finally, minus the 1 for the numerator. And I'll underline that cell. So we're going to say, bringing this into the outer column now. So we're going to take this minus the 1. That's the whole numerator. Home tab, numbers, decimalizing it. And then we're going to say divided by R, the denominator, which is going to be the 10 divided by 2 again. Percentifies it, home tab number, percent, underline. And then we're going to take that number and bring it out here, dividing them out, division problem, dividing, decimalize, home tab numbers, decimalizing it, and then underline, home tab font, underline, and then we'll multiply outer column, multiplying out these items. So adding a couple decimals, home tab number, just a couple decimals. So now we got the 40,941.42. That's the amount that we had from the first 6 payments at the 10%, which we can now generate hopefully 12% on for the remaining time period. And then we have to figure out the annuity. So we have to figure out what we're going to earn on this fixed amount for the rest of the time period. Plus we're going to have to make another annuity for the remaining payments, the remaining 24 payments. Before we do that though, we'll do this one a few different ways again. So we'll do our running balance here. So we're going to have our running balance type of calculation. Basically same table we did before, 1, 2, and then we're going to sum these up. And then I'll center it, home tab, alignment, and center. The payment then is going to be equal to the 6020. That's going to be the value for the first payment, and then we'll do our interest calculation, which will be that 6020 times the 10% divided by 2. I'm going to make that an absolute reference on the percent, so I can copy it down, F4, $ before W, and 7. Then the payment amount will remain the same, and the value is going to be the prior value plus the interest plus the payment. And then we could copy that down, selecting these 3 cells, copying it down, copy that down, and there's the 40,951 once again, getting us to that number. Let's do it again, this time with the future value of an annuity. So we're going to say this is negative future value. Let's say future value, shift 9. The rate is going to be that 5%, or let's pick it up over here. It's the 10% divided by 2, comma, number of periods is going to be the 15 times, not 15. Hold on, that's not right. It's going to be just the 6 periods, because we're just talking the 6 periods now. We didn't get out to the 15, comma, and then the payment amount is going to be, let's pick up the payment over here, the 602057. Enter. So there it is again, 40,951. Let's do it with the tables finally, the amount then. So this is going to be the payment, which is going to be, let's bring it up over here, the 602057. Amount from the table then, amount from the table, straightforward table time, but that's going to be 10% divided by 2, or 5%, 6 periods down here. So we're looking 5%, 6 periods, that's going to be 6.8019, 6.8019, 6.8019, 6.8019, 6.8019. Multiplying that out, and we should then get, once again, close to the 40,951, a little bit different due to rounding. Okay, so now we figured out where we stand at this point in time. Now that I know that number, we're going to figure out the future value of 1 given the new interest rate at the 12%. So this is what we have already after the 6 payments. We're going to figure out what we can get for that at the 12% rate, and then do another annuity kind of calculation for a new annuity, which will be the 30 payments minus the 6 that already took place, or in other words, 24 payments. So now I'm going to do a present value or a future value of this annuity. So I'm going to pick up the annuity calculation, which is over here. I'm going to say that's that 40,000 because this one's a little bit more exact than the one from the table. And then we're going to do this calculation, by the way. Future value equals present value times 1 plus r to the n. So we're just putting that into a table. So 1 plus r to the n. So I'm going to say 1. And then for r, I'm going to use this 12% here, but I'm going to make it like a semi-annual because I want to match that up to the number of periods. So I'm going to make this green down here, so I'm less likely to mess up the wrong rate. I still might, but like I usually work on the green ones, so I'm less likely to. So it's going to be this 12% divided by 2. I'm going to say divided by 2. Percentify that, home tab numbers. Let's percentify that. So we're going to have 6% home tab font underline. Summing this up, this equals the SUM of these two items. And then we'll go ahead and percentify that, home tab numbers percentify. And then to the number of periods, which is now, it was 15 times 2, 30 periods, but 6 has passed, so minus 6. So in other words, I could do it this way. It was 15 times 2, which would be 30, minus the 6 periods that have passed would give us the 24. In other words, 30 periods minus the 6, 24 periods. So then I'm going to underline that, home tab font group underline. We'll bring this out into the outer column. This is the 106% to the power of shift 6, 24, and enter. Adding decimals, home tab numbers, decimalize, underline, home tab font, underline. And then we'll multiply this out, this being the numerator, this being the top number times the bottom number. We're just multiplying out these two numbers. Add a couple decimals up top. So there we have it. So now that we're at the 156, let's add a couple decimals, home tab numbers, add a couple decimals here. So that's where we think we will be then, based on what has already happened thus far. And we're trying to get to 400,000. So we're going to have to set up another annuity, 400,000 minus this amount, and then see how many payments we still need to be making for the remaining 24 periods. And that we'll have to do another annuity type of calculation to do that. That'll be the next component. But before we get there, let's do our little components here, adding the items to this, doing this calculation a few different ways. So we can do a running balance type of calculation here for the future value. This time I'm going to start at 0 and then 1, and then I'm going to go down 24 for the 24 periods, going down 24 periods, and then we'll go home tab alignment, center that. Starting point is going to be then the starting point of the amount that we have in place, that 40,951.42. And then we're going to go and calculate the interest, and we'll just have this grow for the remaining 24 periods at the 12% per period, but that's an annual rate, and these are going to be semi-annual here, so it's going to be 6% per period, 12% per year. So this times, then we're going to say the 12%, and I'm going to divide it by 2. And then I want to make this 12% an absolute reference so I can copy it down. So I'm going to push F4 and then enter. So there we have that. And then I'm going to take the prior value plus the interest, and there it is growing. I'm going to go ahead and just autofill this all the way down, selecting the fill handle, dragging all the way down. And there we have it once again, the 165,810. The 165,810 is rounded 165,809.62. Let's do it with a future value calculation in Excel. Negative future value, shift 9. The rate is going to be then that 12% divided by 2, and the number of periods, hold on a sec, I forgot the comma, number of periods then would be the 15 times 2, the original 30, minus the 6 that have passed, in other words, 24 periods. 24 periods, and then we'll say comma, and then it's a value of 1. It's not an annuity, so 2 commas, and then we'll take the present value of the 40,951.42 and enter. So there we have it again. Let's calculate it with the tables, and then we'll finally get to the last part of this problem. So this is going to be then equal to the amount of the 40,951. Let's pick it up here. Amount from the table now, picking up the proper table. This is going to be then, we're looking for 12 divided by 2, or 6%, number of periods 24. 6 and 24, so 6%. 24 is going to be that 4.0 4.0489, 4.0489, 4.0489, 4.0489, 4.0489. Then we'll multiply this out. And so there we have it again, close to, not exact, because of rounding on the tables, rounding out to 4 digits. Okay, so now we see that we want to get to 400,000. So our goal then was to get to 400,000. What has already happened, we think now it's going to recalculate to get to that 165. So 400,000 minus the 165, 808.20. That's what we need to have a new annuity table to find out what payment we need to make to get up to now the remaining factor that we need, which is the 234,191.80. So we'll do another annuity calculation similar to what we started with, looking for the payment, which we could do algebraically. Ending result being this 234,191.80 equals the P times 1 times 1 plus R, the rate now being 12% divided by 2, to the power of n now being 24 periods, which was 30 minus 6 minus 1 over R, which is again 6, 12 divided by 2. Okay, so we'll do this. Now, I won't do it algebraically. We'll do this with the formula again, and then we'll do it with Excel, and then formulas, a payment formula and a present value or future value formula. So I'll do it with a goal seek. This will kind of lead us into the formula again. So I'm going to assume just like 1,000 for the payment. I'll calculate this, and we'll use goal seek as we've seen in the past. So I'm going to say this is going to then be equal to, we'll put the 1 here. The rate now is going to be the 12% down here divided by 2. So 12% divided by 2. Home tab numbers, percentify, home tab font, underline. I'm going to make this bottom part green so that we can kind of focus in down there. Subtotal equals the SUM of these amounts. Percentify, home tab number percentify. Then we're going to take that to the power of the number of units, which in this case is going to be, remember, it was 30 times 2, and then 6 periods passed. So that leaves us with 24 periods, which are semi-annual or 6-month periods. I'm going to go to the home tab font and underline that. This is then going to be equal to that 106 to the power of shift 624, adding decimals, home tab numbers, decimalizing it, minus 1, underlining that, home tab font, underline. I'm going to bring this, I missed the underline. It didn't underline. It didn't do it. And then this is going to be equal to the 4.04, so on, minus 1, adding decimals, home tab numbers, decimalizing that. And then we're going to have the rate once again being the 12% divided by 2, percentifying that, home tab number, percentify, underline, home tab font, underline, bringing this out to the outer column. This equals this number divided by, numerator divided by the denominator, percentifying that, home tab number, percentify, underline, home tab font, underline, and finally we can multiply this out, this being the 1,000 times this figure we came to. Let's add a couple decimals, home tab number, couple decimals. We'll now use the goal seek to find this number up top. We know the end number needs to be this. This number needs to be that. We're going to change with the 1,000 to get there. So I'm going to go then to the data. We'll go to the what if analysis, goal seek, setting this cell to be the 234,191.80. And we want to do that by changing this cell and then OK. So we do that. There's our end result. So that looks correct. So that looks good. And we kind of backed into that calculation. Let's do it another way. So that means that we're going to have to set up our annuity of another annuity for 24 payments that are going to be the payments of $4,608.66 to get to this number, the 234,191.80, which we need to get finally to the 400,000 after having already received 40,951 from our prior calculation, which we think will generate for that 24 time periods 165,808. So that's where we're at now. Let's do the same calculation a couple different ways. Now we're going to say, let's do a running balance calculation. And I won't use the goal seek here. We'll just do kind of a running balance. So if I started, if this was the payments and we did a running balance and we started with 1, 2, and so forth, adding this on down. We're just going to add this on down. So 24 periods, home tab, and then alignment and center. We're then going to say the ending value is going to be that amount. The interest would then be calculated at the value times the rate, which would be this 12% divided by 2. I'm going to make this an absolute value by selecting F4 on the rate so we can copy it down and enter. The payment will remain the same each time, so I'm just going to say equal the prior payment. The value will then be the prior value plus the interest plus the payment. And then we can copy that on down, selecting these cells, copying that down for the 24 payments. We then get to, once again, that 234,191 or 2 about rounded pennies being taken off here. Let's do it here now. We can do the payment calculation, which is not really one of our present value calculations, or we can use the present value calculation with a goal seek type of feature. Let's do that first. So this is a future value goal seek type of feature. So this will be negative future value shift 9. The rate is going to be, once again, that 12% divided by 2, comma, and then we're going to pick up the number of periods, which would be, we had before 15. 15 times 2 would be 30 because it was semi-annual, but then minus the 6 payments that have taken place already, that gives us the 24. So I'll put that whole equation there just so you can remind ourselves where that came from, comma, and then the payment amount is going to be what we don't know. So I'm gonna basically say that's going to be this cell down here. I populated it here, but let's say we don't know what that is. I'm going to say enter. This payment, let's say it was 1,000 to start with, could then be used to do goal seek. I know the end result should be this 234,192 about, or let's put it over here. Goal seek end goal needs to be this number. So we know that needs to be that, which is also, 234,192. Let's add a couple decimals. So that's our end goal. I'm going to use the goal seek to get there here. So we're going to go to the data tab. We're going to go to the forecast or what if, and then we want to set this cell to be 234,191.80 by changing this cell and OK. So we have that. We can do it in that format, or we can use the payment equation. If we know the payment equation, we could say this is going to be negative PMT. It's not where our major focus is, but obviously it's useful to know. We're going to say the rate is going to be 12 divided by 2, comma, the number of periods is going to be, once again, we could think of it as 15 times 2, 30 periods minus the 6 that have already passed. So another 24, you could put 24 there, comma, and then the present value that we want, and this is going to be the 234,191.80, and then enter. I'm sorry, hold on a second. Not the present value, the future value that we want. So I'm going to remove the present value, comma, comma, future value, because we're not doing the present value, future value, 234,191.80, and enter, and that'll give us, once again, our 4,608.66. Finally, we could use the tables to pick this up. The amount that we're going to have here that's the unknown, so we can say this is what we don't know. I'll make it yellow, and we know the end result, which needs to be that, and so we'll then use the tables. I can go on over here and say, all right, tables. And we know it needs to be 6% and 24 periods. So we're looking 6%, 24, 50.816, 50.816, 50.816, 50.816, 50.816. And then we could back into the amount by taking the total divided by the 50.816, gives us about the same 4608.66, a little different due to the rounding of the tables for the 4 digits. So you can see how we would basically adjust that. Obviously, we made this a lot longer than it needs to be by calculating each component with multiple different ways, but we had this adjustment to the interest rate, and we had to deal with that adjustment to get to the same kind of objective of that 400,000.